Potassium hydroxide, Cloney. A solution, so it's aqueous. Then it gives you what, Hope? Aqueous and water that is liquid. Good. Sharp, sharp. Volgende. Dilute sulfuric acid. Sulfuric acid is what, Rory? Say again? Sulfuric acid.
Oh, acid.
Yeah. And what is the formula for that?
H2SO4.
Yes, and since it's dilute, it's aqueous. Potassium, Sia? Okay, and they say potassium metal. Metal is a solid. What will form, Khali? You had this homework. Where's yours? Why? Why? And you give it. I want to see it when you give that. But, Nora, what do you get as a product? What is K2SO4's name? Yes, and H2. Hydrogen gas, diatomic molecule. Is this equation balanced, Zara?
No, you need 2
At the potassium, you needed 2. Okay, zinc oxide, Seba.
Should I give you the
Please.
ZnOH?
No, it doesn't say zinc hydroxide, it says zinc oxide. Oxide is just oxygen. Zinc is +2, oxygen is -2, so they fit perfectly. They say powder. Powder is a solid. Okay, Seba, what is hydrochloric acid?
HCl.
HCl, and dilute means aqueous. What will form, Niakalo? ZnCl2, yes, aqueous, and what else? H2O, liquid, water. Is this balanced, Niakalo? What do you need to do? Cl, hydrochloric acid. Goed. Sulfuric acid, Kutlano. Formula? SO4, and they say dilute, so it's aqueous, and barium chloride? BaCl2 solution, so it's aqueous. Because barium is +2 and chlorine is -1, that's why there's a 2. What will form, really?
Barium sulfate.
And barium sulfate will be a solid. If you look at those first rules on page 1, it says all sulfates are soluble, meaning aqueous, except when it is bonded to barium. Then it will form a solid, a precipitate. Okay. Dum, dum, dum. Yes?
Why did you swap it around?
Swapped what around? Sulfate and then barium.
Barium and then you say HCl.
What? You said HCl plus barium, like that.
No.
Hey, do
Yes.
It's fine. 2 plus 3 is the same as 3 plus 2. Really, and what else forms? Hydrogen chloride, and that is aqueous. Is it balanced, really? What do you need to do?
Chew by the
Hydrochloric acid, yes. Okay, calcium oxide, Lucidi. CaO, and it says powder, so it is a solid. And no chocolate. Ah, hallelujah. Thank you. Okay, right. Solid because they say powder. Then hydrochloric acid. Tebo, do you have his notes? And why would you have his notes? is the question. Sorry for what? For copying his work? Okay. Okay, the CD, Courtney. What forms?
CaCl2, which is aqueous,
Yes,
and then water.
which is a liquid. Is it balanced?
No.
What do you need to do?
2 in front of each side.
I am very surprised that most of you do not struggle with this. What is the reason that you don't struggle with this? Because in my 10 years of teaching, most learners struggle with this. So I want to know why.
If each and everyone there is something to do, you see, they have own something to do.
That's the word. Their own some to do. Khali, when did you borrow your notes to Tsepo? When? Okay, and before it was with Tsepo, where was it? So no one else borrowed your notes. All on your own. And you, all on your own. Okay. Okay, we will do a quick speed test after this. Say no now. Because you did this for homework, so do you know it? Okay. Cloney, give me magnesium carbonate. S? CO3. Powder, so it means it's solid. Sulfuric acid? And aqueous because it says dilute. What do you get, Hope? Magnesium sulfate. Aqueous, and what else? And what else? Carbon dioxide gas. So you should have seen a carbonate with an acid gives you that. Rory. Sorry, yes, and this is balanced. Rory, copper acetate. What is that? Okay, so yes, but technically that copper must be at the back. It's just the way the compound is formed. Okay, so if you didn't know it now, I'm telling you now. The copper in this compound, it must be at the back.
So it's
Unfortunately. Aqueous. Ammonium chloride, Rory. Cl, also aqueous. And what will form Sia? CuCl2 aqueous and is this a problem? Because this is +2 and this is -1. Yeah, I know. And what else? Okay, so it's ammonium acetate, but you write it like this. The ammonium is at the back. Okay. So thank you, Khali, for pointing this out. Copper, where here I said it's +1. Okay, sorry. So this will be also +1 here. So that will just only be 1 chlorine. And then it is balanced. Okay, so I have your writing book, so I can't give you a writing book. A liquid. Oh, no, it's not very accurate because there will be water present. Yes. Say again? Not the whole period long. Okay, speed test. No, we must just do a bit of work and then. Okay, speed test. Here. You don't have to write phase subscripts. Only those three. 30 seconds. Okay, 5, 4, 3, 2, 1. Switch with the person next to you, behind you, in front of you. Go, go, go. Let's see. Switch with Gali. Gali. Ronnie. Okay. So, listen carefully to where you get marks. Please listen carefully. You get a mark for the reagents, not the balancing, reagents formula, 1 mark. Then product, 1 mark, product, 1 mark, and then 1 mark for balancing. So both reagents correct, product correct, balancing correct. Yes.
The hydrogen doesn't have a 2.
Wrong. No. This 1 mark. The balancing is that gets 1 mark. Okay, then the next one also, reagents, 1 mark. Product, 1 mark, 1 mark. And then balancing, 1 mark, meaning if they didn't put a 2 or a 3 or something in front, they also get a mark. If it's 1 to 1 to 1 to 1, they get a mark.
But if everything is wrong, but the other they didn't put anything.
Then last one, reagents correct, product, correct, and then 1 mark for balancing. You didn't put? Then they don't get that one. 13. Sharp. Switch back. Yes. Then they don't get a mark for balance. No, wrong.
This one.
No, wrong. Okay, switch back. Let me see, who's got 13? Out of 13. 12. 11. 10. 10. Okay. I don't want to know less than 10. Because you all got the answers right in the homework. Still. Okay. Then grade 10s. Grade 11s. Sorry. Oopsie. Let's go to Kahoot. So, open your cell phone if you have one. Here. And you have data. And you Google Kahoot. Yes. No, I don't have enough data to hotspot everyone. I can give my cell phone to a person to play on my phone. Huh? Okay, so if you Google, let me just see who's going to Google from the first. Okay, you Google Kahoot, like there at the top, Kahoot, and then at the top, when you press on the Kahoot link, at the top there's that thing that says play.
You press play. What was for the
Okay, so you press play. Now this is gonna happen fast, so I want everyone there. Ready? Hope, are you playing? Yeah, Carlo, are you playing? Go. Kom, pak Isa. Kahoot. So you Google Kahoot, you press on the link. Then in the top left corner, it's gonna say play.
Maybe it's not claim your first award.
Not Kahoot.
Where was the game played?
I did not say Kahoot, Lord. Did I? Tuma? I said Kahoot. And then you press play. Then the top, play. Must I help anyone? You're there? Where you must enter a code. The thing must say enter pin, game pin, or whatever. Play. Yes, Risha? No. Okay. Just wait, the pin is coming. Okay, everyone is there where they must type in the pin. Yes? Hope? Yes. Okay.
Then what's the price when if you win?
Lollipop.
So top 3.
Oh, you're going to need a calculator. Take out your calculator. Because this is science-related questions. Okay, are you ready? Where's my lollipop? Oh. Okay. Yeah, it's coming. Okay, it's going to say the pin there. You have 15 seconds. Vinnig, Lonnie. Everyone in that wants to be in? Yeah, Carlo? Yes? Then, the fastest you go, the more points you get. It is currently summer in Paris. Is that true or false?
What is false? Right.
Where's me now?
Velocity is dependent on displacement. Displacement is the direct line between start and finish. Quickly! Because it ends where it starts, so the displacement is 0. Okay, when you exhale, what are the products? When you exhale, what's the products? Carbon dioxide and water, oxygen. English, Afrikaans. If Tatiana swims a 200-meter breaststroke, with a time of 139 seconds, what is her speed? What is her speed? Which intermolecular forces are the weakest? Weakest intermolecular forces. You did this! You wrote exam on this! Sweat cools off the body's temperature. True or false? Where's my boko? Okay, fertilizer consists of that. That is the compound. What is the percentage nitrogen in this compound? The percentage nitrogen in the compound. How many elements on the periodic table? Don't look at my periodic table. Six, 5, 4. The longer you take to answer, the less points you get. No?
Yo, man.
Five, 4, 3, 2. Which gold medals are made of which elements? Gold medals, which elements? 5, 4, 3, 2. Optics is the study of what? Light, glasses, sun. Bronze. Does bronze consist of copper and titanium? True or false? Copper and titanium.
It's true.
Which planet is the closest to the sun? Of those there, which one is the closest? Earth. Who's the silver bunny? Okay, when you shot put, it goes with the initial velocity of 10 meters per second. How long will it take to reach its maximum height? You must divide by 9.8. Okay, now we're not going to start again. Nou gaan ons werk. I only have one lollipop. Sharing is caring. I will put in an IOU. I'll organize one for you for tomorrow. Not tomorrow, Monday. Tuesday. Where's my phone? Okay. Alright. Now, we have done so far acids and bases and acid-base reactions that you must know. Now we're going to look at how strong or how weak an acid is with calculations, with equations. Not just this is strong, this is weak. We're going to actually start with calculating. Okay. And that has to do with ionization constants. Ionization constant. Ionization, you know now what that is. Ionization is with an acid, reacts with water. It gives you an ion and the hydronium ion. Right? Ionization. Okay. Now, the ionization constant is a ratio. That is a ratio of products versus reagents. Products versus reagents. So, the ionization constant is a ratio of products versus reagents. Okay. So what we are going to look at is we are going to look at how many products are formed versus how many reagents were used. Or not used, what you have left over. Okay? Because this is, remember those brackets mean it is a reversible reaction. So you can go forwards and backwards and forwards and backwards. See how it's only a dove. Yes. Okay. Right, yes. It's any acid, like this is hydrochloric acid or hydrogen nitrate or whatever. Okay. Hallo, julle moet focus hier. This is grade 12 work. Okay. Now, this formula here is how you get to calculate the ionization constant. So this K is the constant. We talk about Ka for constant of acids or Kb for constant of bases. Okay, so that is how you calculate the constant. What does the square brackets mean again? Square brackets mean something. Concentration of. So how do you calculate this ionization constant? You look at the concentration of the products over the concentration of the reagents, so that it gives you a ratio. So for this hypothetical reaction, Hope, what is hypothetical again? Say out loud. Imaginary, not real, made up, a thought of thing. So for this hypothetical reaction where you have an acid that reacts with water to give you an ion and an ion, then this is the way you will calculate the ionization constant. So the constant is the concentration of the products, so you can see the concentration of the products, over the concentration of the reagents. Do you see that there? And the fact that they are close together means that you multiply them with one another. Okay. Now I explain. I said, if a compound is ionic, no, that's not what I want to say. If a compound ionize or dissociate completely, if a compound ionize or dissociate completely, meaning it completely reacts with water or completely taken apart, then it means, so completely, if it ionizes completely, then it means you get a lot of products. And I think I've said that about 10 times in this chapter. Okay, so that means you get a lot of products. Then we use the symbols Ka for acids, and for bases we use Kb. So constant for acids, constant for bases. Now, if you get a lot of products, then your constant will be greater than 1, meaning it will be high. So if you get a constant and it's greater than 1, it means you get a lot of products. Okay? Then it means it ionized or dissociated completely, and thus it is a strong acid or a base. Because the definition of a strong acid is it ionizes completely. It gives you a lot of products. If it gives you a lot of products, then you have a lot of things here at the top and little things here at the bottom, so your ratio will be greater than 1. If you have a low constant, then it means it ionizes or dissociates incompletely, and thus it's a weak acid or a base. Okay, so this was an exam question. It says, consider the following 2 acids' ionization constants. Okay, here's oxalic acid, has that, and carbonic acid is that. And state with reasons which one of these acids is stronger. So they are both weak acids. How do you know they are weak acids? Because you've studied the list, and it's not the list of strong acids. So they're both weak. But they want to know, of these 2 weak acids, which one is a bit stronger than the other one? Which one will you say? Are we with Rory now? Rory? Holly, if someone's going to hit you one day, I'm going to pretend like I don't see. Because you comment on everyone and everything. Rory, did he say something? Khali, I'm not blind and also not deaf. Okay, Rory, which one do you say? Okay, you say that one is stronger. Why do you say it is stronger? No, you studied that both of them are weak, but you don't know which one is weaker or stronger than the other one yet. Okay, so let's look at what this means. Okay, because I see some of you are also a bit confused. Let's say you get a reaction of, and I'm going to keep this quite simple, hydrochloric acid plus water gives you, and it's a reversible reaction, meaning you go back and forth until an equilibrium is established. You get the hydronium ion and you get the chlorine ion. Yes, you know that. Now let's say at equilibrium, you see what is left at the end. You see you have, let's say, 10 of this, 10 of this, 2 of this, and 2 of this left at the end. So it has reached equilibrium, it has gone forward and backwards, and it has settled with 10, 10, 2, 2. Okay. Now I want to know what is the ionization constant. Then you're going to say the concentration of the hydronium ion times the concentration of the chlorine ion over concentration of hydrochloric acid and water.
When do you know in an equation whether to use the reversible arrows or the
Acid base, reversible.
always? And then the rest is the normal.
Yeah. Okay, so we have 10 times 10 over 2 times 2. 10 times 10 gives you? Do you think I have a baby? Does it sound like babies? Anyway, doesn't matter. 10 times 10 gives me 100. 4 times 4 gives me? 2 times 2 gives me? 4. So 100 divided by 4 gives me 25. Now, is this a big ratio? Because this is a ratio of that versus that. Is it a big ratio? Is it bigger than 1? Yes. So it's a big ratio. What does that mean? It means you get a lot of product, true, and very little reagents, true. So it means this is a strong acid because it has given you a lot of products. It has ionized completely, given a lot of products. Okay, are you with me? So if I just have this equation, and they say that's the ionization constant, then I can immediately say, all right, ma'am, that means this was a strong acid because the ratio is very big, meaning it gives you a lot of products. Without doing any calculations, without seeing any values. From that, I can say that that is a strong acid. Okay? Now they give you this. We can see these are weak acids. How can we see that? Do you see the -2 and the -7? So that means it's actually 0.056 and this one is 0.356. That is their ratios. Those are not big numbers. That is definitely smaller than 1. So from there we can see that they are weak acids. Which one is the stronger acid? Oxalic acid. Why? Because it has a bigger ionization constant. You see that? Okay. So they ask there, which one is the stronger one? You're going to start with saying oxalic acid. And they ask you with reasons. Say again? Yeah, so you're going to say it has a bigger Ka or ionization constant. And then if you have to explain thoroughly, in depth, then you'll go further and you'll say, thus it ionizes completely to give a lot of hydronium ions. All right. So in grade 11, you do not have to know how to do this calculation. You do not have to know. In grade 11, you only have to, I'll give you these things and you just have to argue. Is it big or is it small? What does that mean? Okay. Right, now I'm going to stop there for today. You may back away.